Hey everybody, thanks for coming to the last talk of the conference. I know it's probably been a long day, so I appreciate you coming here. My name's Colin Estep, and I work at Netskope Threat Labs. We are the research group at Netskope, and while we focus on a lot of different types of threats that are posed to enterprises, we mostly focus on cloud security. So today, I'm here to talk to you about insider threats, exfiltrating data before they leave an organization. So I plan to fill this whole time, but I will be at the happy hour after this, so if there's any questions, please feel free to come talk to me. I'm a people person, so I'd be happy to talk to you. And if anybody in the crowd doesn't get this reference, please do come talk to me, because we need to rectify that. So I wanted to start off with an insider threat story. So let's say I'm an employee at a company, and I'm not, super disgruntled or anything like that. It's kind of a normal situation, but maybe something happens. Maybe Elon Musk just bought the company, and he says he's about to clean house. So I decide, you know what, I think I'm going to look for another position. So on the timeline here on the slide, you'll see we're at about 75 days out from my departure is when I decide maybe I'm going to start looking. So I start my job hunt process. And maybe I'm talking to recruiters, talking to people in my network, trying to see what's out there, what's the market like, and time is starting to pass. So now at day 50, it's going pretty well. Like, the market's not bad. Maybe I have some possibilities here. Maybe I even have an interview or two. And I realize, you know what, this is going to happen. So I realize I want to start thinking about what that means. And I decide I want to start taking some data with me. Like, there's things that I've worked on at this company. And so, let's say I worked on a really big project. And I worked super hard on it. It took a lot of work, and I might be doing something similar in my next role. So I decide, you know what, I want that project. I want some of those files that I created. So I log into my personal Google Drive from my corporate device, and I save off these files. So time continues to pass, and maybe I have some personal stuff on my laptop, cat photos or whatever. I upload those. Who cares? That's fine. But then maybe there's also some complex processes we developed, and we have some guides along those, and they're like a competitive advantage. And I really don't want to reinvent the wheel next time. So I take those too. And now, we're getting towards the end of my job hunt. Maybe I get a couple of offers. I'm negotiating things. And I realize, hey, there's also some source code I wrote. Again, I don't want to reinvent the wheel if I don't have to. I'm taking that too. So I've got a start date at my new company, and I go ahead and resign. I'm giving my 2 weeks notice, no big deal. Maybe now the company is putting some additional scrutiny on my activities, but as you can tell, from 14 days out to 50 days out, there's a lot they could have missed. So I resign. I don't do a whole lot in the last 2 weeks, and my last day, maybe I realize I want to take some contact info. Maybe the company cares, maybe they don't. And that's it, and I leave. Now in security, I feel like we love talking about these fringe cases, like the spy from China or the person who wanted to burn down the whole company before they left. And those are things we got to consider, but I feel like a lot more commonly, we would experience something like this. Maybe the person doesn't even realize they're violating all these corporate policies when they're taking data, but it happens. So why would you even take this time to sit here and listen to me? Why am I up here talking about this? Well, part of what I've been doing at Netskope is developing user and entity behavioral analytics and deploying those into production. A lot of different detections, and I've been working on it for a while, and a lot of people have been using it. And so we've been able to accumulate a lot of data. And this presentation is sort of, that data is the foundation for this presentation, where for the first time, I'm sharing some of the results that we found and ways that you could maybe mirror this in your own organization. So what kind of data are we looking at? This particular data set came from over 200 different organizations. It was about a 9-month period where we observed 58,000 people that left their employment that were confirmed. And just to give you a preview of our findings, some of what I'm going to be talking about, out of the 58,000, we found 15% connected to their personal apps and moved data of some type, and 2% of the people that left were confirmed as violating corporate policies, maybe even doing something illegal. And what kind of data did they target when they did take something that we didn't want to be taken? 70% of the data taken was composed of intellectual property and PII. And for anyone who's not familiar, PII is personally identifiable information. So this is like names, addresses, email addresses, things like that. So now that I gave you sort of a preview of this, what are we going to go further into for the rest of the talk? Well, first, I want to drill more into the problem and make sure that everyone's on the same page about what we're going to be addressing. Then I'm going to go through an overview of our approach. So this is kind of giving you the high-level view of what you need in your own organization to address this problem. Then we'll go into more detail about finding data exfiltration. How do you actually accomplish that? And then I'll go through what I think might be next for our research, at least from Netskope's perspective, and leave you with some takeaways. So first, the problem. Insider threat is a very general term. So for the context of this presentation, I'm just defining an insider as someone who has exfiltrated data, sensitive corporate data, through cloud apps. So sensitive data means this is data that could be harmful to your organization if it gets out. And I don't mean compromising photos of your CEO. I mean like payment records, health records, things that are regulated where you might get fined if it's breached, or also competitive advantage, your intellectual property that you're developing that gives you an edge. You don't want that stuff getting into the public domain either. And what wasn't in scope for this study was insiders plugging in a thumb drive, downloading files, and then taking it, or anything else physical, really, printing out documents that they shouldn't have printed, or taking pictures of screens with their phones. While these are all valid things that organizations may need to consider, it just wasn't in scope for this. And in case anyone's not too familiar with insider threats or maybe doubting why this is even a concern, there was a 2020 report that connected insider threats with flight risk employees very tightly. And whether you're working at a nonprofit, a government agency, or a company, everyone has flight risks. We all have employees that will be turning over at some point. And then data exfiltration, we've had this explosion of data in the last, couple decades, and more organizations than ever have this type of sensitive information in some form, whether it's just, people's emails or it's health records. And more, at least, especially in Europe and North America, there are a lot of precedents being set that organizations are liable when this data is breached. So I think it's worthy of every organization to take a moment and think about this problem and consider what their strategy should be. Okay, so that's the problem, and that's kind of why it's important. So what is our approach here? So I wanted to start off with architecture. This is sort of step one. What's the bare minimum that you need in order to start thinking about this problem? Well, you'll see on the slide we have devices on one end, our monitoring systems in the middle, and then apps sort of on the other side. So every organization probably has corporate devices, whether they're running an endpoint agent or not. Hopefully you have some type of proxy in the middle that's grabbing traffic from your corporate devices and can show you what's happening when people are accessing unmanaged apps or websites, as well as the managed apps. So for anyone who's not familiar, managed app just means this is like your organization's Google Drive or Microsoft OneDrive, things like that, that the organization uses to facilitate its business. And then we also have unmanaged devices. So this could be someone's personal laptop or phone that they're using to access the corporate data. So they're using this to access your managed apps. And in this case, we may not have anything in between. So at the very least, you're going to want to have audit logs being ingested from these managed apps so that you can get events that show you who's accessing the files and what they're doing and when they're doing it. And then that way you have a little bit more complete picture of what's happening. And once you get this data, you might be an international organization. You may need to take into account certain privacy concerns of your own employees and things like that. So maybe you need anonymization, you need something redacted or encrypted. So you do that, and then you put it into a data lake. And hopefully you'll have a data lake that's full of events that are normalized, it's accessible, you can query it without things breaking. And so that's what we use for analysis. So once you have the data, what do you need to do? How do we find insiders once we grab all of this data and put it into a huge data lake? There's really three main signals that we found to be most useful for this. The first one is direction. So you need to be able to tell where the data is headed, whether it's being downloaded from corporate apps or uploaded to personal apps. Being able to differentiate that is key. The second one is the nature of the data involved. So you want to be able to easily identify which files contain your really sensitive information. Third is the volume. So this is when you want to know if somebody's downloading or uploading stuff more than they normally would. So the first signal I want to talk about is direction. So labeling applications. I was actually surprised when we started this process how easy it was to sort of differentiate between things that we knew were business and things that we knew were personal. And basically it comes down to this. If you have traffic going to something like Google Drive, as long as the data already shows you that it's Google Drive and it shows you some information about the credential being used, about the username being used, you can start to make these labels yourself where you say, hey, you know what, I know that I work at Exxon, and so Exxon.com is going to be our business Google Drive, for example. And Gmail.com should never be used for anything corporate. So I'm going to label that personal. And same thing for Yahoo Mail or Hotmail or whatever. In our case, we have a wide variety of customers, so we don't always have a priori knowledge of the domains involved. So there might be somebody logging into foobar.com, Google Drive, and we just label that unknown because we don't know if it's relevant or not. It could be RVAsec, they volunteer outside of work and they just happen to use their corporate device there. So we don't know. And on the right-hand side here, you see the breakdown of what we found in production. We had 50% business traffic, 15% that's clearly personal, and then 35% that was unknown. Next is the nature, so labeling data. I think most mature organizations are going to have data loss prevention, or DLP, deployed, and that's really helpful. If for some reason you're a smaller organization or you're just getting started with this, if you wanted to do a proof of concept and you don't have DLP, there are ways to label files in Google Drive or OneDrive where at least you can start to say, hey, this is a secret project, or this is, intellectual property. So that's a little bit of a workaround. But assuming you have DLP, it's great because you can set up policies that they automatically sort of tell you when files are being moved that match certain conditions, and from those conditions hey, this thing had intellectual property or data that was in scope for compliance, or maybe even secrets like API tokens. So if you're able to get these DLP violations, they can provide you a nice signal there. And so what would all this look like? I just wanted to give you a quick example here of what it might look like. This is very simplified and sort of contrived, but it'll get the point across, where I log in with user@gmail.com to my Google Drive. I've labeled that personal, and you can see here I'm uploading a file called blackproject.docx, and that file actually set off a DLP violation for secret project code names. So that means that this file had code names that we defined as that pertain to secret projects. So that's a good indicator that blackproject.docx probably has intellectual property we don't want getting out there. Okay, so that's a quick overview of some of the building blocks you need in place. Next, I want to go over some high-level results from this study. So first, we'll talk about departures. Again, this is 58,000 people leaving over a 9-month period. And you may be asking, what kinds of companies or organizations are you seeing these people leaving from? So we have a little breakdown here of the industries that were involved in this particular data set. And you'll see, it's a pretty good spread. It's not like it's all technology companies or anything like that. We do have a lot of insurance for some reason, and technology closely behind that. But then the rest of it is pretty well spread out through other industries. So I think we had a good representation overall. And these are from all over the world. So again, how many people moved stuff? From what we found, we were able to confirm 15% of the flight risks moved some data. But this includes benign cases. So this includes people that just were backing up their cat photos or whatever. But we were able to confirm that all the people that moved that data ended up leaving. And you may be asking, when did they start doing this? So this is another sort of subtle thing that I had in the story, but we found that 50 days from departure is when, up to the minute of departure, 75% of the data gets moved. So as you can tell from the chart, it does swing up very high towards the end, but if you want to catch the bulk of it, if you want to catch like 75%, you got to go a little bit further out. You got to go out like 50 days to catch that. And then what sort of data gets moved? So on this chart, you'll see on the left side, we've got the different file types. And then on the right side, the apps that they used when they were moving it to their personal instance. So on the left side, we've got everything from plain text files to source code, PDFs, and of course the biggest block was images. And then something that surprised me, maybe it shouldn't have, but something that surprised me was we had over 80% of the people moving it to Google. So every time it was something personal, there was like an 82% chance that it was going to Google Gmail or Google Drive. Okay, so that's just people leaving and not necessarily violating anything, but the overall body of people moving data. Next, we're going to drill into more on the people who did take data that was concerning. So again, data exfiltration, this is sensitive data that could hurt the company. So 2% of the people who left took something that violated policies. This group of people also seem to be, like if you're monitoring 50 days of data, you're going to get somewhere around 84% of the data that's being moved. So this is way before the 2-week notice. With this group of people, if you monitored 30 days, you may still get around 75%. And so here, let's look closer at the data that they targeted and the apps they used. On the left side, you see the DLP policies they violated. Now, Netskope's platform provides a lot of different components. So we were fortunate that a lot of these customers use our DLP, and so I had the ability to look at what sort of policies they had set up for this. I could see what kind of violations. So I can tell you, intellectual property and PII are at the top like I mentioned in the beginning, 70%. If you put those two together, you're at about 70% of the data that was taken. But we also have financial, healthcare records, source code. You'll see encrypted here on the slide, and that just means that they encrypted the files before they moved them. So they used something like PGP or something like that where we couldn't see what the data was, but it violated a policy. Well, it at least showed up as encrypted files. And then again, the apps used were right around 80% Google, followed by Microsoft OneDrive. But it's still Google by a mile. Okay, so that's sort of the overall results. I wanted to drill more into finding data exfiltration and kind of geek out a little bit about how you guys could do this. So data exfiltration, of course, is all about data movement. So when we're talking about that, there's three main signals: direction, nature, and volume. And then we have the components here on the right side that kind of help us derive those signals, where we have instance labeling, data labeling, and anomaly detection. So we've also been able to deploy a lot of different detections at Netskope and see how they work. So I wanted to go over some categories of detections with you. So let's say you're early in this process, you have a data lake, and you're able to query it, but you don't have these other components yet. If you were to implement heuristics, these are sort of like basic rules. In this example, it's something like, hey, alert me if somebody uploads more than 100 files in a day. But I don't have DLP, I don't have the applications labeled, so I don't know any more detail really. It's just really basic alerting based on a threshold. Then you implement anomaly detection, and now you get a behavior baseline, and so you can see if there's a spike. And let's say you also apply the application labels to go along with that. Now you can tell if somebody's uploading to their personal app and if they're doing it more than they usually do. And then the last one is combining all three, where, hey, there's a spike of uploads, it's going to their personal drive, and it's violating our policies. Now, getting to that third area could be a lot of work. So is it worth it? Well, based on the data we have, looking at organizations that have 3,000 plus daily active users, if we look at the heuristic as sort of a baseline, this is like the basic one, you could be looking at 215 alerts to get one true positive of somebody moving stuff that you care about. If you implement anomaly detection with the application labeling, we found a 15-time advantage there, where we're getting more like 14 alerts per true positive. And then lastly, with DLP involved, we had 5 alerts per true positive. So with alert fatigue being a major issue, it might be worth it to put in that work. So the one signal I haven't talked much about up till now in detail is anomaly detection. So let's dive into that. So what is anomaly detection? It's another one of these general terms like machine learning or something. What does it really mean? So I wanted to ground it in something real. When I say anomaly detection, I'm talking about 3 basic things: spikes, first occurrence, and rare occurrence. So this is what we're doing with user and entity behavioral analytics. So spikes are the user downloaded more files or uploaded more files than normal. First occurrence is like, hey, Colin just uploaded some stuff to an S3 bucket called Evil Corp, and no one else in the company has ever done that. That's probably something I want to know. And then rare occurrence. This could be like, hey, somebody didn't log into Slack for 90 days and then they just did. Maybe that person left the company and they forgot to disable the Slack access. So that's another one that could be useful. But for the volume signal that we're going to be talking about, it's mostly spikes. Now, when you're looking at baselining behavior, there's really three main areas that we're doing it. There's the user level, so we're baselining just that user's behavior. And so if we have a spike for that user, it's kind of a lower severity thing because maybe they're just, doing something that they don't normally do, but it could be benign. It doesn't stand out as much. Peer group models, that's where it's like, hey, you're in HR, or you're in marketing, or you're in engineering, and now you're doing something strange for that entire group. That's a little bit higher severity because what you're doing doesn't fit into a business case for that business unit necessarily. And then we have organization level models where we're baselining all the users of the organization. So if you download 2 terabytes from Google Drive in one day, and no one else has ever done that, that's probably a higher severity thing that you want to take a look at sooner rather than later. So I wanted to dive a little bit more into building models here. What you're going to want to do is think about your use cases, and based on the use case, you can select what features you want. So in this case, we're talking about data movement and things like that. So my example here is files downloaded per day is my feature, and that's what I'm going to model. And maybe I model it across the user, peer group, and organization level. So what we've been doing at Netskope is we use something called kernel density estimation, and we use a Gaussian kernel. So this is the second part that says fit data into a distribution. So on the right side, you'll see these orange dots. I don't know if you guys can see it super well, but these orange dots represent data points for how many files were downloaded per day for this particular user. And so we're plotting them out, and you'll see there's a nice cluster right around 20. So on the left side, you see the probability. So it shows like as there's more data points at a certain level, that has a higher probability, meaning that it's pretty normal for that person. And then we track it over time. So these models, what we're doing is we're only allowing it to keep 6 months worth of data. So as we accumulate data over time, and it goes beyond 6 months, we start rolling off the old data because it's stale. And then as new events come in through our data pipeline, we analyze those events. So what you really want to do is you want to make sure that it fits the entity that you're modeling, like the organization or the user, whatever it is, and fits the feature. So not like authentication events, for example, don't have download information. So we wouldn't use that in the model. So as we find valid events, we save it to the model and find the probability. So here you see a new data point came in, and it's above 80 downloads for the day. So next, we need to decide if we're going to trigger an anomaly. It's not a given, because when you set up these models, you don't want to start triggering anomalies right away because there's no baseline. So everything is strange. So we typically use about a month or so as our guide to say, let's let it learn for a few weeks, and then it's mature enough to start making decisions about what's an anomaly. And there's additional conditions we might have in place. Something we've been doing is we have some additional heuristics around, hey, we might want to have a super useful anomaly, so we look at other anomalies and other events that have happened, and if everything matches up, then we trigger this thing. And then if it matches all that stuff, then we trigger an anomaly. And like I said, it's probably going to be spikes in the case of data movement. And this is more of a reference slide, but just to sort of walk you through what I'm talking about here. On the left side, we have behavior, and this is, the behavior that's happening if it's triggering DLP violations, spiking downloads, spiking uploads. In the middle, we have the signals, and then on the right side, the anomalies that kind of fit with that. So you'll see it kind of goes from top to bottom, progressively more useful, I think. And so at the bottom, what we have is this sort of correlated upload that was preceded by download spike and DLP violations from the uploads. So we call this potential sensitive corporate data movement. And this is sort of the anomaly to rule them all. So once we get this, we know we want to investigate that. And we've deployed 70 different models to our production environment. I say on the slide that it's learned from hundreds of organizations. It's really more like thousands, but at least hundreds. And some of the models have been learning for over 2 years. And during that time, we've spent a lot of time monitoring them, making sure that they're not triggering garbage, and really trying to work it out to make it as useful as possible. And coming from an incident response background, I like sort of thinking about things in terms of action. So how do you take action on something like this? Say you had set all this up and you're getting your sensitive corporate data movement alert. What do you do then? Well, this is where you would triage any of those alerts that you're getting, and at least it would point out to you the user that's involved. And this should not be, like, at least if you were able to accomplish what we've done, you should be getting single-digit volumes from this. This shouldn't be more than 10 per month that you're getting. And so from there, you could examine the user's DLP violations, and the files being moved, you could examine more closely. Depending on the organization, of course, like you may have just file names and some other metadata, but you may have other organizations that have forensics in place that capture the file content itself, and you're able to look through it. But either way, this should be a fairly manageable process. We've been finding that we can make a decision about most of these alerts within an hour max. So let's talk a little bit about actual case studies, actual things that we found. What does this look like? So the first case study is an employee departure. And this was confirmed as an insider threat by the organization that we worked with. So they exhibited this behavior where they uploaded 2,700 files to their personal Google Drive. They've set off 1,500 DLP violations. And there was also a first occurrence signal here where this happened to be the first time they logged into their personal Google Drive from this device. So, we saw all of that, and 12 days later, the person departed the company. Second case was actually not a departure, or at least not that I'm aware of. So the user uploaded 1,900 files to their Google Drive, set off a bunch of DLP violations around patents and PII, and the organization we worked with said, yeah, this contained legal cases and financial information that we really didn't want leaving the building. And then case number 3 was actually benign activity. So this person uploaded 500 files to their Google Drive, set off hundreds of DLP violations for PII. It just turned out that this person, for whatever reason, had a lot of their life on this corporate device. I don't know why. They had their taxes and bank records and scans of their driver's license and everything else on there, and they just happened to move it all. So, but even in these cases where it's benign, we're able to figure that out pretty quickly. So that's kind of it for data exfil. So I just wanted to go into a little bit about what might be next here. So our current limitations, we only analyze data movement via cloud apps. I'd love to expand that a little bit, and I think we'll be able to, at least for like thumb drives and things like that. Also, the scope was that insiders ended up leaving the organization, but like I mentioned in the case studies, there's some that don't. So we might be focusing more on just data exfil for other studies. And then the unknown traffic. I had mentioned earlier, we were able to label 35% unknown. I'd love to get that number down so that we're a little bit better about what is just corporate and what's not. And then some ideas for future development. I think, a lot of you are probably thinking what I thought, which was, hey, it'd be great if we could identify flight risks before they exfiltrate data. And so I'm not sure if we can do that yet, but looking at job hunting activities, reduction in business-related activities, these are things we're kind of exploring. Additionally, I would love to be able to incorporate more metadata about the files that are downloaded, such as who owned this document and where was it before? Was it in a location that seems like it's, where you store your secret project info? That could be very useful. Okay, so we're nearing the end here. So our findings, again, are that 15% moved data to personal apps, 2% violated corporate policies. They took intellectual property and PII. So that was 70% of the data that they took. Takeaways that I wanted to leave you with. Again, if you can monitor 50 days of data, I realize people might have budgetary constraints and other logistical problems with this, but if you can, you should probably go for around 50 days of data as like a rolling window that you can monitor for user activities. And then the 3 signals that I've been talking about in this are the direction, nature, and volume. So this is combining these 3 signals are really what's going to give you that insight that you need to make fast decisions about whether or not you need to investigate a user further or take some other action. And then lastly, investigating those alerts, if you're able to combine them, it's very manageable. Some of the reactions that I've had in the past when I've talked about this were, hey, that all sounds great, but I don't have time to investigate all this stuff. But the reality is I've been living this for a while, and it's not that involved. You would think it would be, but once you get the signals right and things are tuned well, you can do this in a very manageable way. So if you like content like this, please check out the Netskope Threat Labs blog. I've got the QR code here if you want to scan it. Otherwise, the link is in the slides too. We try to keep it up to date with stuff that we're doing and stuff we find interesting. So, yeah, thanks for your time.